Hi guys, so this is your test review for Unit 10. So what we're going to do is we're going to review the parametric equations that we've done most recently, but also the vector stuff that you guys saw on your quiz. So the very beginning of this is going to look very similar to your quiz review. It's honestly the same directions and different numbers for a lot of these. So the first thing we're going to do is, given an initial point and a terminal point, we're going to write the component form of the vector. So remember, component form, pointy brackets, x comma y. So the way this works, you can do it algebraically or graphically. If I do it algebraically, I'm going to do the second point minus the first point. So 12 minus negative 7, that's going to give me the x component. And then for the y's, negative 2 minus 2 is going to give me the y. So this would be 19, negative 4. The other way you can do it, or you can use this to check your answer, is graphically. So if I go to the point negative 7, 2, that's where I'm starting, and I'm going to end at the point 12, negative 2. That helps me see the direction pretty clearly. So I'm going right 19 and down 4 if I actually graph it out. All right, let's look at the other one. So again, I would do the second point minus the first point, so the x's and then the y's. So negative 6 minus 8 is negative 14. 11 minus negative 4 is a positive 15. And again, if I want to check this by graphing, I'm going to go to negative 4 is where I start. Negative 6, 11 is where I end. So again, that left distance, I went left 14 and I went up 15. So it matches what I got algebraically. All right, magnitude and direction. We've done this many, many, many times. So magnitude, remember, Pythagorean theorem. Make sure that negative 2 is in parentheses and you put the squared outside the parentheses. So that's going to be the square root of 29. Direction, that's the angle. We're going to do tan inverse y divided by x. Now remember, if the x is negative, if it's in quadrant 2 or 3, the x is negative, we have to add 180 to our answer. So let me go ahead and grab a calculator real quick to figure out this one. So we're going to do tan inverse, so shift tan. Make sure, again, your mode here should be in degrees. Okay, our mode should be degrees. So tan inverse, 5 over negative 2, and we're going to add 180 to that, which gives me 111.8 degrees. So that's my direction. Square root of 29 is my magnitude. Very same thing on the next one, okay? Magnitude, Pythagorean theorem, 4 squared plus negative 5 in parentheses squared. Again, remember that negative 5 is in the parentheses, the squared is outside the parentheses. So that's going to give us the square root of 41. We're going to do tan inverse for the angle, y over x. And again, this time when we plug this in, we're going to get a negative angle, and that's okay. It is a negative 51.34 degrees. Now, I don't have to add 180 just because my answer is negative. I would only add 180 if the x coordinate were negative, or the x component. And in that case, the x component was positive, so it was okay to leave it there. All right, so now we're going to do the exact opposite. We're going to take the magnitude and direction, and we're going to find the component form. So we need an x component and a y component. So the x component, 5 cosine 110. The y component, 5 sine 110. At this point, you would plug this into your calculator. Make sure that you are still in degrees. So my x component would be negative 1.71. And my y component would be 4.7. All right, same thing on the next one. If you notice, this is actually a unit circle value. So if you're using the Casio, you may see kind of a square root answer instead of a decimal, and that's okay. But if you also could technically do this without your calculator, because these are on a unit circle. The cosine of 30 degrees is actually a value you know. It's the same thing as the cosine of pi over 6. That value is root 3 over 2. So you end up with 23 root 3 over 2, or you could get the equivalent decimal, which is, I need to plug that in, 19.92. And then 23 sine of 30. Sine of 30 is 1/2, so this would be 23 over 2 or if you do the decimal, 11.5. So the Casio is going to give you something that looks like this. If you're using a TI or just finding the decimal, it would look like that. But either way, it's magnitude times cosine of the angle for the x, magnitude times the sine to get the y. It's the exact same thing we did on our quiz. All right, then we looked at operations. So remember, when we add and subtract these vectors, the x's go together and the y's go together. So I'm going to do u minus v. So let me go ahead and change that. So that's a negative v. And then a negative w. Let me go ahead and change those signs. And now I can add them all up together because I changed those values. So that's going to be negative 5, 13 as my final answer. All right, let's do the next one. I'm going to go ahead and do negative 3u. So I'm going to take u and multiply it by negative 3. 3v, so multiply that by 3. And then negative 2w. So that's going to be negative 8. And then that's going to be negative 4. Then we can go ahead and add them all up together. So it's going to be 12 minus 17, which is negative 5. And then negative 21 minus 24 is a negative 45. Negative 45 minus 4 is a negative 49. So that is my final answer here. All right, and then the last thing that we did with vectors were our word problems. So on these word problems, we kind of followed the same process. We found the component form, we added the component forms together, and then we took the resulting component form and we found the magnitude and direction. So let's start with Judah. All right, Judah is pushing a box with a force of 10 newtons at an angle of 71 degrees. So component form, the x would be 10 cosine 71. The y would be 10 sine 71. All right, let's look at Jordan. Jordan has 5 newtons of force at an angle of 12 degrees. So he would be 5 cosine 12, and he would be 5 sine 12. So I'm going to go ahead and plug those into a calculator and get those decimals. So I've got 10 cosine 71 is going to be 3.26, and then 10 sine 71 is going to be 9.46. Then we'll do Jordan. 5 cosine 12 is 4.89, and 5 sine 12 is going to be 1.04. Once we have those component forms, we add them together, and that's going to be the resultant. So add your x's together. That's 8.15. Add the y's together. And that's going to be 10.5. So that is the resultant of those two forces in their directions. So once we find that resultant, what we want to do is we want to find the magnitude and the direction. So the magnitude, Pythagorean theorem. So we're going to do 8.15 squared plus 10.5 squared. So I'm going to plug that in. So I've got 10.5 squared plus 8.15 squared. So I'm going to get a magnitude of 13.29. So that's my magnitude of the answer. Then I'm going to go ahead and do the angle. So I'm a little bit out of space here. Let me go ahead and put the angle up here. Tan inverse y divided by x. We do not need to add 180 because the x is positive. This is in the first quadrant. So I just need to plug this in, and I'm going to get an angle of 52.18 degrees. All right, let's do one more word problem. This one's going to have some directions on it, but they're pretty straightforward. So a plane is flying at an angle of 75 degrees north of east. So remember, here's east, 75 degrees north of east. That's just a normal 75-degree angle. So for my plane, I can go ahead and do a magnitude of 400. So 400 cosine 75. 400 sine 75. So I don't need to do anything crazy with the angle because that angle is just a regular 75-degree angle. Now, same thing with the wind. Okay, my wind is 23 degrees north of east. Well, that is going to be a normal 23-degree angle. So our wind would be 30 cosine of 23 and 30 sine 23. So now I'm going to go ahead and find what those component forms are. So I've got 400 cosine 75, which is 103.53 for the x component, 386.37 for the y component. Add that to the wind. I've got 30 cosine 23 and 30 sine of 23. Once I have those two component forms, then I can go ahead and add those together. So do the x's together, 103.53 plus 27.62. That's going to give me the resultant here is when I add them together. My x's will be 131.15, and those y's, I'm going to take that 386.37, add it to the 11.72. I don't know why I wrote a plus there. And that's going to give me that y component of 398.09. All right, so now we're going to find our answer here is the magnitude and direction of this resultant. So for magnitude, 131.15 squared plus 398.09 squared. Again, I'm going to plug that into a calculator. And that gives me a magnitude of 400, that looks like a 9, sorry, 419.14 miles per hour. Let's find the direction. Tan inverse, y over x, so 398.09 over 131.15. We do not need to add 180 because this is in the first quadrant. The y or the x coordinate here, well, they're both positive. So there's not a negative x, so we can just plug it in as is. And I get an angle of 71.77 degrees. So this plane will be 419.14 miles per hour at an angle of 71.77 degrees. All right, so all of that was just reviewing the stuff that was on your vectors quiz. I know a lot of you guys did really good on that. Review those quizzes, do some of these examples, and as long as you kind of know those formulas to convert, you should be in great shape for vectors. Now we're going to go into parametrics. All right, so the first part was just drawing the graph, and this should be the easiest part. All right, you don't need a calculator to draw these graphs. All we're going to do is take the given t value and plug it into t in each of those equations. So let's start with x. So negative 2, plug it in for t. 2 times negative 2 plus 1. Negative 4 plus 1 is negative 3. Okay, now let's plug in negative 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Plug in 0. Plug in 1. 2 times 1 plus 1 is 3. Plug in 2. 2 times 2 is 4 plus 1 is 5. Now, one thing you might notice that might help you kind of check your answers, you see how these are getting bigger by 2 each time and how that was 2 times t? So that's just something you could use to possibly check your answers if you need to. All right, now let's go to the y equals, or the y of t. So take t, plug it into the y equals equation. So 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. 3 times negative 1 minus 2 is negative 5. 3 times 0 minus 2 is negative 2. 3 times 1 minus 2 is 1. And 3 times 2 minus 2 is 4. So then what we're doing is we're going to plot these points. So I'm going to plot the point negative 3, negative 8. Then I'm going to plot the point negative 1, negative 5. Then I'm going to plot the point 1, negative 2, 3, 1, and 5, 4. Now, the order that we plotted those points in as t got bigger shows us the direction. So we're not just going to connect these dots. We're also going to show the direction in the order that we went in. So I went from negative 3, negative 8, then I went to negative 1, 5. I ended at 5, 4. So the direction that I moved, I'm going to put arrows on my graph to show which way I went. So don't forget those arrows. That's what makes this graph different than just a regular line. All right, let's try another one. Same process. This one will look a little different because it's something squared, but it's still the same process here. Take -2, plug it in for t in the x equals equation. And remember, when it's a negative, just like we did with vectors, you have to put that -2 in parentheses and then square it. It's a -2 times a -2, which is +4. 4 minus 2 is 2. Then you do the same thing with -1. Then you do the same thing with 0. Then I plug in 1, and then I plug in 2. So that's going to be 4 minus 2, which is 2. All right, now let's plug in those y's. Okay, plug it in for y. So 2 times -2 plus 1 is -3. 2 times -1 plus 1 is -1. 2 times 0 plus 1 is 1. 2 times 1 plus 1 is 3. 2 times 2 plus 1 is 5. So once we have those points, let's plot those coordinates. So 2, -3 is the first point to plot. And again, pay attention to the order here. -1, -1, -2, 1, -1, 3, and 2, 5. So this is the direction that I'm moving. So that is the direction I'm going to show with my arrows. All right, last one, same idea. Take the t's, plug them into the x equals equation. So 3 times -2 minus 1 is -7. 3 times -1 minus 1 is -4. 3 times 0 minus 1, -1. 3 times 1 minus 1 is 2. 3 times 2 minus 1 is 5. Plug them into the y equals equation. We use a different color here for the y. All right, so I've got -2 squared minus 1. And again, the -2 is in parentheses. That becomes +4 minus 1 is 3. -1 squared minus 1 is 0. 0 squared minus 1, -1. 1 squared minus 1 is 0. 2 squared minus 1 is 3. So then again, remember, plot those ordered pairs. So -7, 3, -4, 0, -1, -1, 2, 0, and 5, 3. And again, pay attention to the order that you plotted them in. This is the direction as my t's get bigger. We're going to show that direction with the arrows. You have to include the arrows on your graph. Again, that's what makes these different than every other graph we've been plotting so far. All right, so the hardest thing you're going to do algebraically probably is finding this rectangular equation. It's kind of a little bit like a system. What you're going to do is you're going to take one of these equations. I usually use the x because my y is already by itself here. I'm going to take this top equation, and I'm going to get t by itself. So I'm going to add 7, and I'm going to divide by 2. And I'm going to write it as 1/2 because it's going to make it a little bit easier to write my final answer. So I can distribute that, and this is what t is. Once I know what t is, I'm going to take what I have here for t and plug it in to the t in the y equals equation. So y equals 5 times, and I'm going to replace that with the value of t. Then all I have to do at this point is simplify. So 5 times 1/2 x, that would be 5 over 2x. 5 times 7 over 2, that's 35 over 2. If I want to add 1, I'll get a common denominator. And I get 5 over 2x plus 37 over 2. And that is my rectangular equation. That is my equation where I have solved for y. All right, let's go to the next one. Same thing. Take that first equation and get t by itself. So -1 divide by 4. And I'll distribute. So 1/4 x minus 1/4. Once we know what t is, it's going to take the place of t in the y equals equation. So this is going to become 1/4 x minus 1/4. So when I distribute, that'll be 3 over 4x minus 3 over 4 minus 5. So that's going to be 3 over 4x. If I want to add those together, I need a common denominator. And I get negative 23 over 4. So that is the rectangular equation here, the y equals. And again, that's probably the hardest thing algebraically that we have to do. All right, so now we're going to look at the word problems for these. All right, so on these word problems, what we're going to do is we're going to write a set of parametric equations for each problem. Now it's set, remember, that means there's an x equals equation and a y equals equation. Now, like we said, we're going to give you guys those equations that are written in the box up here. Okay, that's exactly how you'll see it written on your test. You just need to know what to use and what the letters stand for. So a quick little refresher about what those things are. Remember, the x equals equation, we don't really need to think about. That's just the x equals equation. V is the initial velocity. T is your time. That's going to be your variable. It's going to be a t in your equation. And then theta is the angle. The difference between the y equals equations, 4.9 is for meters and the 16 is for feet. So if our equation uses feet, which a lot of them will, we're going to use the negative 16t squared equation. All right, so let's go ahead and write our equations. A football player kicks a ball from ground level with an initial velocity of 75 feet per second. Oop, forgot my t. At an angle of 55 degrees. So that's my x equals equation. Y equals, okay, we're in feet, so we're going to use the negative 16t squared plus 75t sine 55. The h is the initial height. In this case, there is not an initial height. He's kicking it off the ground, so we don't need to worry about any plus h here. If your equation does not look right, more than likely, most of the time, it's either your t settings are wrong, but even more frequently, you've just typed your equation in wrong. So make sure that you have a t in all of those places. Make sure there's a plus in between those. But again, this is all one term. There are not any pluses in between any of those. So just be careful when it comes to actually typing your equation in. So I'm going to go ahead and pull up my calculator. All right, so I went ahead and reset my memory so we can go over the settings that we need to change here. I'm going to go to my graph. So first thing, let's make sure we're in degrees. So shift, menu. Let's scroll down to angle. And let's make sure we're in DEG for degrees because we are taking the sine and cosine of a certain number of degrees. Now, more than likely, you've already fixed this setting because you've already used the parametric or the vector stuff, but just in case, it's good to make sure. Again, you can kind of check up here at the top, and it should say DEG right there if you were in degrees. Now we need to change our mode to parametric. So what we're going to do is we're going to do F3 for type, and then you see PARAM. I will press F3 again. Now it's in parametric mode. So now we can go ahead and type that equation in. So that equation was x equals 75t. Remember, press the normal x button. And then cosine of my angle, which was 55. And then my y equals was negative 16t squared plus 75 sine 55. Nope, and I did it again. See, if I were to graph this, it would not have looked right because I'm missing a t. Plus 75 t sine 55. So always double check your equations. Make sure you have them in there correctly. All right, so what I'm going to do now, before I graph this, I'm going to change my window. And the most important thing to check on your window are your t settings. Okay, we can mess with the x and y's by kind of zooming in and zooming out, but our t settings need to be correct. Right now, my t max is 360. That means this is going to graph 360 seconds of this path, which is way too much. It's just going to take a long time. So while it won't make your graph look wrong, it might just take a really long time to graph. So I'm going to change that to 5, okay, because I don't think this ball is going to be in the air for longer than 5 seconds. Now, if you ever see just kind of part of a graph and it stops, you might need to make that Tmax a little bit bigger. But typically for a lot of the problems we see, 5 seconds is probably enough. This one's really important. This is the PTCH. That's like your T step if you're using a TI, the T step. This is how much your T is going up by whenever we trace. I'm going to set that to 0.01. That's a really important setting to change. That way when we do trace, our answer is going to be pretty accurate. Okay, now I'm going to go ahead and try and graph this and show you guys our window's obviously not working. Okay, we really can't see a good picture of this graph. And if you want to kind of zoom out and scroll around, you can, and you'll be able to get an okay picture that way. But if we want to get a really accurate picture, I'm going to actually change my window settings. So the way I do that is I'm going to go to F3 for window. X is the horizontal distance. So we're going to start at 0. Sorry guys, forgot. We're going to start at 0, and then we're going to make our max however far this ball is going to go. And again, we can kind of guess here, okay? I'll start with 100, and we'll see what it does from there. Our y is our height. Again, I'm kind of going to guess. I'll start at 0, and then I'll make my height 100, and we'll just see how I can see on this picture. And that's not a bad picture, okay? We're pretty close at this point. But in order to get closer, to seeing the whole graph, I run out of room on the x's. So my x max needs to be bigger. So I'm going to go to my x max, and now let's just try 200. And let's see if we can see this whole path. And we can. There is the path of my football. All right, so now let's answer the questions that we have. I'm going to answer them the first time around just by tracing. Then I'll go back and show you the algebra behind it for those of you who are working out that way. So first you want to figure out how high is the football after 1 second. All right, well, let's trace. And since our t-step or our PTCH is 0.01, that's how much the t-values are going by. So let's just scroll until we get a t-value of 1. Because remember, t is time here. So if t is 1, that's 1 second. Well, that tells us a lot of things, okay? How high it is, that's the y equals value here. So after 1 second, it is 45.44 feet high. The horizontal distance, that's the x equals here. So this is 43.02 feet horizontally. All right, next part. How many seconds is after how many seconds is the ball at its highest point? So let's scroll until we get to the highest point. So again, we're looking for the biggest y that we can get. So we can get pretty close just by looking, but I'm going to actually find those values here. So 58.97 is about as high as I can get. Okay, right there is going to be my highest point. So that is going to be, the time is the t-value. That's 1.92 seconds. And if you're off by like 100th or so, that's okay. You'll be pretty close. The maximum height, that's the y. So that is 58.98 feet. And then how far away is the ball when it's at its highest point? That is the x here, which is 82.595 or 0.5 or 0.6. So how far away horizontally? That's x. Maximum height, that's y. How many seconds? That's t. All right, let's find a little bit more information about this situation. How long is the ball in the air? So remember what that means. We are looking for the very end of this graph. So we're going to go all the way to the end. Once those y's are negative, it's no longer in the air. It has hit the ground. So you're looking for the y value either right before that point, or you are looking for, there we go. So negative, so somewhere right in between here. So that line's kind of in my way, but it looks like it's about 3.84 seconds, or about 3.83, so somewhere right in that range. Whoops, thought I was writing and I was not. There we go. All right, so how long it's in the air? That would be the 3.84 seconds. All right, how far away is the ball from the kicker when it hits the ground? So when it hits the ground, that's what we just found, 3.84 seconds. How far away it is, that is 185.19 feet. Then the last one, there is a goalpost 150 feet away that is 10 feet high. Will the kick be good? So what that means, when I'm 150 feet away, I need to be at least 10 foot high. So let's scroll and let's see where this graph is when the y is, or the x is 150. So let's go to an x of 150. So right about here. So when x is 150, I have a height of 19 feet. Well, that is above 10 feet, so yes, the kick will be good because it is a higher point. If you want to kind of see this visually, if you wanted to, you could actually graph a dot for where that goalpost is. I'm going to go ahead and go back to this. I'm going to make this 150 for an x and 10 for a y, and it is going to plot a dot where my goalpost is. So there's my curve, and that little red dot, that's where the goalpost is. And you can see it's clearly going over the post, which means the kick is good. All right, so let's look at this last word problem. We're gonna go ahead and write our equations. So we're gonna have an x equals and a y equals. So in this case, we have a cannon shooting from 5 feet off the ground with an initial velocity of 100 feet per second at an angle of 39 degrees. So 100t cosine 39 is your x equals. We're in feet per second, so negative 16t squared plus 100t sine 39. And we do have an initial height this time, so I do need to add a plus 5 here to the end. Make that a little clearer to see. There we go. So I went ahead and already typed my equations in. So go ahead and plug those in if you have not already, but 100t cosine 39, negative 16t squared plus 100t sine 39 plus 5. Again, that additional extra height there. I'm just going to graph it using the settings we just did, and we can see from there if we need to add more. All right, so it looks like I need a little bit more of my x's. So I'm going to go to my window. I'm going to make my x max larger. And I'm just going to double it to 400, and we'll see what we get. So there we go, and there's my graph. All right, so now let's answer our questions. How high is the cannonball after 1 second? So let's trace, and let's go until we get to the t-value of 1. And again, I'll show you guys here at the end how to do these algebraically if you want to or you prefer that way. But I'm going to go ahead and scroll here to where t equals 1, and my computer's going very slow, but you get the general idea here. All right, so when t equals 1, it gives me the horizontal and the vertical distance. So how high is it? That's the y. The y after 1 second when t is 1 is 51.93 feet. The horizontal, the x, that's going to be the 77.71 feet. After how many seconds is the ball at its highest point? So we need to keep tracing a little bit to get to the highest point. So let's keep scrolling until we get to that highest point. All right, so looking for the biggest y value that we can find. So we're up to 66 now, and let's keep going until we get to the highest possible point. Again, if you can't tell from the picture, look at your numbers. 66.6, 66.7, 66.8. And at that point, my y's start getting smaller. So 66.88 looks to be about the highest y value that I'm going to get here. So somewhere right in this range, I'm going to use the 1.97 as the time. So that is how many seconds. That's the t value. The maximum height, that's asking for the y. The y at that point is 66.88 feet. And how far away is it? That's the x. So the x at that point is 153.1 feet. All right, and let's answer these last couple questions. How long is the ball in the air? So how long the ball is in the air, we got to trace all the way to the end. Once those y's are as close to 0 as we can get, that's when we know the ball is no longer in the air, because right now it's getting lower and lower and lower, and when it's at the ground, the y value is 0. So right in this range, somewhere between 4.01 and 4.02. And I think the 4.01 is a little bit closer, so we'll use that as my time. And remember, this is the t value. All right, how far away is the ball when it hits the ground? So at this point, what's our x value? So our x value at this point is 311.64. All right, the last one, there is a 20-foot high wall of 300 feet away. So 2 different ways to work this out. Let's scroll to where our x is 300. So that's pretty close to where I just was. So right here, in between 3.86 seconds and 3.87 seconds. Well, if you look, my height here is about 9.5 and 8.9, somewhere in between those two numbers. So probably right around 9 point something feet. That is definitely not high enough to go over a 20-foot wall. So that does not have the height, so no, it will not go over the wall. The other option, if you want to actually plot a dot to show where that wall is, it's 300 feet away and it's 20 feet high. So if I do 320, that's going to plot a dot there, and we can see there's my dot, that little tiny red dot. That ball is not high enough to go over that height of that wall. So it would hit the wall, it would not go over. Okay, because again, there's my dot, there's the wall. The ball runs into the wall. All right, so if you feel comfortable with the tracing method at this point, that's really it for the review. I am going to go back through these last two questions, though, and kind of show you some of the algebra and the other ways that you can find them. All right, so I'm going to go back on these word problem questions. And like I said, I'm going to show you guys kind of the algebra behind them here. So you don't have to use this method, but if you prefer this to tracing, or if you really want to get as exact as possible, then this is what we can do. So let me rewrite those equations. So I've got 75t cosine 55, negative 16t squared, plus 75t sine 55. How high is the football after 1 second? We would take the y equals equation, and I would just plug in 1 for t. Plug that straight into a calculator, and that is going to give you your answer. So again, if you're using the calculator at this point, you would be in run matrix, because this is just your normal equation at this point. So if I plug all that in, then I would get a height of 20.86 feet. And that didn't really make a lot of sense. It's because I typed something in my calculator wrong. So the equation I wrote is correct, but if I plug this into my calculator, 45.44 feet. That would be your height when t is 1. All right, how far horizontally? Take the x equals equation, plug in 1 for t. So 75 times 1 times the cosine of 55 is going to give me a horizontal distance of 43.02 feet. After how many seconds is the ball at its highest point? So this is where we're trying to find the vertex of the y equals. So negative b over 2a. So this would be negative 75 sine 55 over 2 times negative 16. So I would just plug all of that in. So I've got negative 75 sine 55 divided by negative 2 times 16 would give me 1.92 seconds. So that's how we can find it algebraically. Now that we know the time, we can plug it into the x equals and the y equals equation in order to get those two heights. So the maximum height, we plug it into the y equals equation. So 1.92 squared plus 75 times 1.92 sine 55. So I am going to, again, I'm plugging this into run matrix at this point. I'm still in degrees, that has not changed. And I end up with 58.98 feet. That is the height after 1.92 seconds, which is the time it takes to be at the highest point. All right, how far away is it? That means we plug it into the x equals equation. So plug that in. So 75 times 1.92 times the cosine of 55. And that gives us a horizontal distance of 82.595, so 0.6 feet. All right, let's look at a couple more here. We got to talk about when it reaches, how long is the ball in the air? Okay, how long is the ball in the air? So that means when y is 0. Okay, when y is 0. So when y is 0, then what I would do here, I would take my equation, negative 6, the y equals equation, plus, I'm trying to remember what my velocity was. I think it was 75 t, forgot my t, sine, and my angle was 55. So in order to solve this, we can factor out that t value. So let me go ahead and just erase this. I'm going to factor out the t. Set each one equal to 0. So t equals 0 is obviously an answer when we'll get 0, but that's not how long it's in the air. That's where we're starting from. Then we'll take the other. Set that equal to 0. Divide by 16. And plug that into a calculator, and that's going to give us how the time that it's in the air. So 75 sine 55 divided by 16, and that is going to give us our height of our time of 3.84 seconds. So that's how we can solve for this algebraically instead of changing. Once you know the time and how long it's in the air, then what we can do is we can take that, rewrite that. So we can see that second question. How far away is it when it hits the ground? So take the x equals equation, and then we're going to plug in that time that we just got. Plug that into a calculator. So 75 times 3.84 cosine 55. It's going to give me a horizontal distance of 165.19 feet. The last one's a little tricky to do algebraically, but you definitely can. So what this is saying, there's a goalpost 150 feet away that is 10 feet high. Will the kick be good? So what we would need to do here algebraically, we would need to figure out what time my football would be at a distance of 150 feet. So I would do 150 equals 75t cosine 55. So to find t, I'm going to divide by what's with it. So 150 divided by 75 times the cosine of 55 gives me 3.49 seconds. Well, now I want to know the height after 3.49 seconds. So we're going to plug that in to the y equals equation. So I'm going to plug all that in. And that's going to tell me that at that point, the height is 19.53 feet. 19.53 feet is going to be high enough to clear that 10-foot high goalpost. So because that height is more than 10 feet, yes, the kick will be good. All right, so again, that method you do not have to use. For some of you, it may make more sense, and if that's the case, then great, go ahead and keep using it. Otherwise, tracing is going to get you pretty close for the purposes that we're using these for. So it's just important to understand what these different variables mean in each of the different problems.